We're solving problem 7 from the MA exam. A particle travels in a straight line. Its velocity as a function of time is shown below right there. Which of the following shows their velocity as a function of distance from its initial position? Obviously, I've exaggerated these graphs to show you the answer choices, but basically, it can either be straight, curving inward, or curving outward. And these answer choices are just a mixture of all of them. Now, for this problem, we can use one of our kinematic equations where it says that our velocity squared is equal to our initial velocity squared plus 2 times the acceleration times x. Now, we can actually split this into 3 parts. This graph into 3 parts. This is 3, 2, and 1. And obviously right here, well, it just stops moving because our velocity is at 0. Now at part 1, well, let's see here. Our velocity 0 is, our initial velocity is 0. So v squared is 2ax. Taking the square root, I should write that. V squared is 2ax. So therefore, square rooting both sides, v is the square root of 2ax. Now our second part of the equation, in this case, since it's a constant velocity, at least in the problem, my drawing's pretty bad, we therefore know that we let this point be the initial velocity because we split it into 3 parts, rather this part. So we now know that v squared is equal to, or our velocity is equal to our velocity 0. So we have that. So this is just a straight line. So that straight line is constant throughout the whole shape of this graph, and you'll see in the answer choices, this is always true because there's always that straight line in the middle. Let's move on to the third component, this sliding down. Well, we see here that we know that this is negative because it has a negative slope. So this part has to be negative because it's accelerating slower. So in this case, v squared is equal to our initial velocity squared minus our 2ax. Therefore, square rooting both sides, v is equal to the square root of our velocity initial squared minus our 2ax. And we want to see a graph in which this, or one of these increases. Well, what really determines it is just these 1 and 3. Since we know that, this one's increasing and this one's decreasing, so we know that these 2 sides have to be matching. Otherwise, it would be very weird. So that leaves us with, 3 options, A, B, and C. We know that A is wrong because upon looking at our first part of it, our function of velocity is not linear. So it's either B or C. Now we can because this is a square root and we don't have plain values here, you can just substitute a normal integers and then graph it. So like square root of 1 is 1, square root of 4 is 2, and then eventually when you graph it, you'll see that it makes an arc curving upward. It would make the same arc curving downward. So our answer is C for this problem.